Good day. In this video we're going to show you that a tree diagram can help you to solve a probability problem. It is about a cyclist that is cycling in the rain and on a dry day, and the probabilities that he will fall or not fall on the rainy day, or fall or not fall on the not rainy day. Let's discuss the problem. It says when it rains, a cyclist might fall. The probability of rain, we're going to capital letter R, on any day is 25%. Remember, we can write it as 25%, 0.25, or a quarter. I'm going to change everything to decimals. So we write the probability is 0.25 for raining. Then the not raining probability will be 0.75. The probability of not raining is 1 minus the probability of raining. That's why the not raining is 0.75, which we write over there. And remember, every set of branches must add up to 1. Next they say the probability of falling on a rainy day is 20%. You can write it as 0.2. If we go up that arm on the rainy day, probability of falling, we write in the 0.2 there. Then the probability of not falling is 1 minus the 0.2, which is 0.8. which we write on the bottom branch. But remember, the 0.2 plus the 0.8 must give us 1. Next they say the probability of falling on a dry day is 4%, or 0.04. So we write the 0.04 on this branch for the falling, and the 0.96 on this branch for the not falling during the dry day, not raining. Again, those two probabilities on that set of branches add up to 1. Just remember, the question would only have this information. They say on a rainy day, a cyclist might fall. Probability of rain on any day is 25%. Probability of falling on a rainy day is 20%. Probability of falling on a dry day is 4%. Everything I'm going to show you now is what you must know with your probability knowledge. So after you've drawn your tree diagram, now we'll look at what they ask of us. The first thing they ask us to do is to draw a tree diagram, which we've done, and calculate the probability of rain and falling, rain and not falling, not rain and falling, and not rain and not falling. If you go up this branch, you'll have the rain and falling. So the probability of rain and falling, I'll multiply the 0.25 with the 0.2. and get my answer. Then I'll go up this arm, rain and not falling, multiply the 0.25 and the 0.8 down here, and get my answer. And then from the probability of not rain and falling, I'll come down the not rain branch, go up the falling branch, I'll multiply 0.75 with a 0.04, and get my answer, 0.03. Lastly, I'll times the 0.75 with a 0.96 and get the probability of not raining and then not falling, which will be 0.72. And remember, if you add these final answers, they always add up to 1 again. Next, they ask us to calculate the probability of falling. So we'll be working out both these roots, probability of rain and then falling, plus the probability of not rain and falling, which we can write out like this then. And that'll give us 0.08. The probability of falling is 0.08, or 8%. Please stop the video and get your brain around this. Lastly, they ask, determine whether the events raining and falling are independent. I like to write down the formula that they taught us. If the probability of raining times the probability of falling is equal to the probability of rain and falling, then the two events are independent. Then I break the proof up into two parts. I say on the left hand side, the probability of rain times the probability of falling. Fill in their values. Use your calculator, answer 0.02. You work out the right hand side, probability of rain and falling. And we have worked it out going up that branch there. That gives me 0.05. Then we can see that these two answers aren't the same. So the left-hand side is not equal to the right-hand side. So rain and falling are not independent, because the probability of raining times probability of falling is not equal to the probability of rain and falling. Please stop the video and get your brain around this. Please indicate whether you liked or disliked the video and subscribe to the channel. You may message me at this number to arrange personalized lessons in mathematics. Enjoy mathematics.